Today we're going to be doing a little bit of exponent practice. So we're going to start by going over the 4 exponent laws that we have learned so far. So we have learned an exponent law for multiplying things with the same base, for dividing things with the same base, for a power of a power, which means when you have one base with more than one exponent, or what it means to have a power of 0. So the first thing we learned was the multiplication rule. So if I have x to the a times x to the b, when you multiply two things with the same base, the base stays the same, so it's still x, and then we add our exponents. So this would be x to the a plus b. When we divide, if they have the same base, the base stays the same, so it's still x, and then I subtract my exponents. So x to the a divided by x to the b should be x to the a minus b. When we have power of a power, we learned that when you have one base with more than one exponent, you can simplify that by leaving the base the same, so that's x, and multiplying your two exponents together, so to the power of a times b. And then the last rule we learned was the power of 0, and we learned that anything other than a 0 to the power of 0 equals 1. Now, we didn't talk when we learned the power of 0 about what 0 to the power of 0 is, and it's kind of controversial. Some people think that 0 to the power of 0 should also equal 1, and some people think that 0 to the power of 0 should equal infinity, and there's a lot of debate about it. So we're just not going to talk about that right now. All right, we're going to start with a question that says simplify using exponent laws. So I have x to the 7 times x to the 8 in a bracket divided by x to the 3 to the power of 5. So when you are simplifying a question that has more than one operation, so it's got multiplication and division, or it's got, division and an exponent, or multiplication and an exponent, you want to try to follow order of operations. So we're going to try to follow BEDMAS, which means we are going to start with B brackets. So when I take a look at this question, there are two different sets of brackets. There's one set of brackets here, and there's one set of brackets there. In the first set of brackets, is there anything for us to do? And the answer is yes, there's multiplication inside that bracket. So I can start by multiplying these together. And that's what we're going to start with. So this is going to be x to the power of, and we learned that you add your exponents when you're multiplying if you have the same base. So I'm going to add 7 and 8 together to get 15. So this is x to the power of 15. Does it still need to be in a bracket? Not really. It doesn't have an exponent or anything on the outside. So I'm just going to leave x to the power of 15 divided by. Now I do have another bracket here. Inside the bracket, I just have x to the power of 3. I don't have any multiplication or division inside of there, so I don't really have anything to do. So even though there is a bracket there, it doesn't really count as a bracket when we're doing BEDMAS. So this is going to be x to the power of 3 to the power of 5. All right, so if we move our way through, we've talked about the brackets. We're going to do exponents. Now, all of these have exponents. We are talking about an exponent on an exponent. So that would be over here when I have x to the power of 3 to the power of 5. So you're looking for a single base that has more than one exponent on it. So I am going to leave the x to the power of 15 for right now, and the division. Now, x to the power of 3 to the power of 5, when you have one base with 2 or more powers, we multiply those powers together. So 3 times 5 is 15. Okay, so now I have x to the power of 15 divided by x to the power of 15. When you divide two things with the same base, the base stays the same, and then we subtract our exponents. So 15 take away 15 is actually 0. So I have x to the power of 0. Now, normally if I had an answer like x to the power of 3 or x to the power of 5, I would be done. But I do know what to do with the power of 0. Anything to the power of 0 is 1. So this actually equals 1. So this whole big expression really just equals the same thing as 1. So I like this question because we did some multiplication, we did power of a power, we did division, and we did the power of 0 all in the same example. So I am going to take a look at the next one. We have 7, a to the 10, b, all to the power of 4. So we talked about this before, that when you have more than one term, like when your term has more than one part, right? So this has a coefficient and 2 variables, right? That a power of 4 applies to everything inside that bracket. So that means 7 is going to be to the power of 4. A to the 10 is going to be to the power of 4. And the b is going to be to the power of 4. Now that b has a secret exponent of 1. Actually, so did the 7. Anytime you don't see an exponent, it does have a hidden exponent of 1. So I could write b to the 1 to the 4, but it is actually easier just to write it as b to the 4. And it does follow the rule because 1 times 4 is 4. Okay, so I have 7 to the 4. I'm going to leave that for a minute. I have a to the 10 to the 4. So a to the 10 to the 4, I have a power on a power. So that means I'm going to multiply those together. 10 times 4 is 40. So I get a to the 40 and then b to the 4. Now we could stop there. We've used exponent laws. We have simplified, but often we will work out what the coefficient is. So on my calculator, I am going to work out 7 to the power of 4, which is 2,401. So I have 2,401, a to the 40, b to the 4. Okay, last question in this section. I have 70x to the 25 divided by 35x to the 20 in a bracket divided by, to the power of 10. So if I'm working my way through BEDMAS, and I forgot to mention that on the last question, I do have a bracket in that last question, but there wasn't anything to do inside the bracket. There wasn't any multiplication or division or anything like that. So here I do have a bracket, and inside the bracket we do have some division. So I'm going to start with the division inside the bracket. Now when I'm dividing, our power, so our exponent law says that if the bases are the same, you can subtract the exponents. But if they have a coefficient, we just divide the coefficients. So what makes something a coefficient and not a base? So if something is a coefficient, it's in front of a variable, and it's not going to have a visible exponent, which neither of these have. So I'm going to do 70 divided by 35, which is 2. And then x to the 25 divided by x to the 20, I'm going to leave the base the same, which is x, and then I'm going to subtract my exponents. 25 take away 20 is 5. And then that is still in a bracket to show that it's to the power of 10. Okay, from here, there's nothing left to do in the bracket, so I'm going to move on to the exponent. This exponent is on the bracket, which means everything in the bracket gets that power of 10. So the 2 gets the power of 10, and x to the 5 also gets the power of 10. So I have 2 to the power of 10. When you have a power on a power, we multiply. So that gives me x to the power of 5 times 10 is 50. Now I could leave it, but I think I'm going to work out what 2 to the power of 10 is. So 2 to the power of 10 is 1,024. X to the power of 50. Okay, so you can join me in the next video to learn how to do our next question.